Assalamualaikum. Okay, so for our first lab, alright, we will start with activity 1 R load. Okay, so first of all, we need to identify the component that we need to have in our lab. Alright, so first we need to have the AC voltage. Okay, just find this component. Right, find AC voltage here. Okay, so then just put here for the AC voltage, and then we need to have the diode. Right, so for the diode we just search for 1 and 1199C. Right, so this diode that we need in our lab. And after that we need to have two resistor here. Okay, go to basic. Alright, so for the first resistor, normal resistor here. Okay, just put it here, and after that the variable resistor, okay, here. Alright, so then just put here, and lastly we need to have ground. Okay, so go to the source. Alright, so just pick the ground here and put here. Okay, so this is the component that we need on our lab. Alright, so okay, for the instruction, we need to set the AC supply to 100 volt. So change the voltage to the 100 volt, and for the frequency we need to change it to 50 Hz. Okay, right, so for the resistor, right, we need to change it to 100 ohm. Okay, and for the R2, okay, so for the R2 we need to change the resistor to 1 ohm, not 1 kilo ohm, 1 ohm only. Okay, so this is the component that we need in our lab. Okay, so for the component for measure the value, alright, we need to have 3 multimeter. Okay, so for the first one we put here. Okay, so this one is to measure the voltage output. Okay, so the second one here. Alright, so this one multimeter, we need to we use it to find the current output, and the last one is here. Okay, put here to find the voltage AC. Okay, alright, so for last one, right, to find the voltage maximum voltage, okay, we need to have this oscilloscope. Okay, so these are the component that we need. Okay, one AC supply, one diode, and one resistor, and one variable resistor. And for the component to measure, 3 multimeter here and 1 oscilloscope. Alright, and don't forget about the grounding here. Okay, so and this for the second step, we need to connect the circuit like the lab sheet. Alright, okay, after connect the circuit, we will get just like this. Alright, okay, so alright, after we get this circuit, we just run the simulation to get the result. Okay, so that's the result that we will get. Okay, so stop the simulation. Okay. So for the XM3, alright, so this is the value for the AC supply, and for the XM1 here, this is the value for voltage output, and for the current output. Alright, so this is the value here, you will get this. Okay, and the last one is voltage maximum. Alright, so this is the value. Okay, we just move it to this. So we will get the value for the voltage max is 98.908 voltage. Good. Alright, so that's for the activity 1.
Hello, hi, Assalamualaikum. My name is Muhammad Fatur Rahman bin Rustam. My number metric is DE190162. Okay, I'm from group 31 for laboratory power laboratory lab 1. Okay, so now I will explain about the activity 2, which is RL load. Okay, firstly, we will construct the circuit as shown in the figure 1.2. Okay, by using the power supply, which is AC 100 volt. Okay, here as a figure. And then I will measure the VAC, Vout, output current by using the multimeter, and will record the data in table 1.2. All the data will record in table 1.2, and then measure the Vmax, okay, for the waveform. The waveform will be using by the oscilloscope by using the multi-sim software, and then I will repeat the step 2 to step 5 by adding the inductor L2 in series to existing load L1, and repeat the step 2 to 5. Okay, we will measure all the Vout, Vmax, and output current. And then the third one is I will add in the parallel diode, which is the freewheeling diode, and also repeat the step 2 until step 5. Okay, so now let's we construct by using the multi-sim. Okay, this is all the component. I will connect between the component to construct the complete circuit. Okay, so now okay, this is the ground. We need to add the ground for the reference. Okay, so for the waveform, we need to connect to the oscilloscope at the channel 1 as a V out here. Okay, so now we run the circuit. Okay, so okay, now we will adjust the parameter and the scale to obtain the. Okay, so we can see the noise in here between the waveform. Okay, so we'll add the multimeter to obtain the reading. Okay, so for the Vmax is 31.118. For the Vout is 38.14. Okay. Okay, so now already read the reading. We'll need to adding the additional L2 bit in series between here. Okay, we connect. Value same, 50 millihenry. So we will run. Also, we get the same waveform, which is still there's a noise between the waveform. So we can see there's no effect, which is the rectifier is not complete cycle in stable condition. Okay, for the reading, max is 30.64. Okay, for the VAC is 38.95. Okay, so that's the multimeter for the Vout and Vmax. Okay, so now the last one is we need to add the diode for the freewheeling diode. Okay, in parallel. Okay, we run the simulation. Okay, the waveform already in half wave rectifier in there's noise. That means the wave is already in good condition, in stable. Okay, for the reading, okay, Vmax is 31.18 for the VAC, Vout 38.028. Okay, for the current, okay, supposedly current all is in same value, so we need to connect here for the to obtain the value of current, output current. Okay, so for the current is 0.3 ampere. Okay, so now we record all the data in the table 1.2. In table 1.2, okay, for the VSC is around supposedly 100 volt as the power source. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and good evening. My name is Muhammad Akmal bin Rizwan and my matric ID is AE190023. So today I would like to conduct the simulation for activity 3, which is the brake rectifier, experiment 1, which is the uncontrolled rectifier for subject BEV30401, Power Engineering Laboratory 1. So as you can see right now on the screen, this is the circuit that we need to connect to conduct the experiment. So the first equipment that we need to use is the AC voltage source, and then we need to use the 4 diode to act as the bridge rectifier, and then we have the resistor and the variable resistor. The resistor is 100 ohm and the variable resistor is 1 ohms, and then we need to use the multimeter to calculate the voltage source, the output voltage and the output current. Next, we need to use the oscilloscope to measure the waveform of the maximum voltage, the output voltage and the inverted output current. So as you can see right now, this is the circuit that I've created by using the multisim. So as you can see, this is the voltage source, which is 100 volt and 50 hertz, and then there is 4 diode which I use to act as the bridge rectifier, and then we have the multimeter, this multimeter to calculate the output current, this multimeter to measure the output voltage of for this load, and then we have the oscilloscope to observe the waveform of the output voltage, and then we have the oscilloscope at this area to calculate the voltage of the source voltage, and to measure the waveform of the source voltage. So as I run the simulation, so as you can see, the waveform for the output voltage is full. There is no negative cycle because, as we know, the AC, the function of diode is to transform the AC into the DC voltage or DC current. So this is the waveform for the output voltage, and then we can see this is the AC voltage waveform, which is in the sinus, which is a sine wave. So now we take a look at the current. So this is the current for the circuit, which is 303.29 milliampere. And then we take a look at the voltage. As you can see, this is the output voltage, which is 30.33, and then for the maximum voltage is 61.91. So that's all for me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.